Hello everyone, today let's solve the problem number 347, top k frequent elements. So given an integer array nums and an integer k, we have to return the k most frequent elements we have been given, right? So we have been given an integer array nums, you can clearly see here, which consists of the elements 1, 2, 3, right? So we have duplicates of 1 and 2, but it consists of the numbers 1, 2 and 3 here. So given an integer array nums and an integer k, so we have an integer k as well. What is k? Basically it is the most frequent elements, right? So we may return the answer in any order. So they have given us that we might, or we can return the answer in any order. That's what they have given here, right? Let's come to the first example here. So in this case we have this one array of nums here. It consists of 1, 2 and 3. We need to find the two most frequent elements, right? K equals 2 they have given. So in this case we have to find the two most frequent elements. By looking at the array, we can say that this one is repeated thrice, right? One is repeated thrice, 2 is repeated twice here in this case, and 3 only once, right? 3 only once here. You can clearly see 1 3 times, 2 twice, and 3 once here in this case, right? So the first most frequent element will be 1, the second most frequent element will be 2. That's what we need to return. In this case we need to return 1 comma 2 within the array. So here the output is 1 comma 2, same thing, right? So here in this case for the second example we have 1 and k they have given 1 in this case, right? So here only one element we have, the most frequent element, first element will be 1 itself. In this case we will be returning 1 within the output, right? So I hope this is clear. They have clearly or they have wonderfully given the example, right? So that we understand this one clearly. So I hope this is completely clear. So I hope the question is clear and what we need to do is completely clear as well, right? So first, as usual, let's discuss the approach followed by the edge cases one by one, and then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. Here, first thing that we need to consider here is, we are going with the, first thing we need to consider here is, we are going with the hash map plus priority queue approach. We'll be making use of the max heap or the max priority queue here. We'll be making use of the max priority queue, or you can just call this one as hash map plus priority queue, right? So here, first thing we need to consider here is, as I have said, we will be making use of the hash map plus priority queue approach, right? So we'll be going with hash map and priority queue. So here I have considered the same example, means the first example that they have given in the question, right? So here we already know we have we need to find here in this case k equals to 2. I forgot to write k equals 2 here. K equals to 2 here. So the most frequent element, by looking at it, we can say here 1 should come first and 2 should come first, right? That is how we got the output here. So let's discuss the step-by-step execution here. First step here is we have to count the frequency. We have to count the frequency of each element, right? First we need to count the frequency of each element to return the most frequent element accordingly with the k, right? So let's count the frequency first in the first step. So we will create a hash map. That is the reason we'll be making use of the hash map to store the frequency counts of each number. We have to store the frequency counts of frequency counts of each number somewhere. So for that purpose we'll be making use of the hash map in this case. So we have the array 1 1 1 2 2 and 3 right here. In this case 1 is repeated thrice. In this case 1 is repeated thrice, 2 is repeated twice, and 3 is repeated once. This we will store this one in the hash map. This one will be storing this one in the hash map. This is fine, right? Easy to understand. Let's move on with the second step here. We will be making use of the priority queue. So we will be making use of the priority queue or max heap or max priority queue in this case. So we will insert the elements into the priority queue. So we will be inserting the elements into the priority queue, nothing but the max priority queue here, based on the frequency. Based on the frequency means based on the higher frequency. So here 1 is repeated thrice. So first here 1 will be inserted. So heap order, first 1 will be inserted, right? So let me delete this one. No need of this one. First 1 will be deleted. First 1 will be inserted as it is repeated thrice. 1 is with the highest frequency, right? 1 is the element with the highest frequency 3. So second 2 will be inserted as it has the frequency count 2. right? And third 3 will be inserted as it has the frequency count 1. So based on the frequency count or based on the frequency, we are inserting the elements into the priority queue, nothing but max PQ, right? Max priority queue or max heap. You can consider max priority queue, right? So let's move on with the third step. Easy to understand, right? Second step. Let's move on with the third step here. Just give me a second here. So after this one, after using the priority queue, after getting the heap order, we saw the heap order in the previous step, right? So we have to extract the top k elements. So accordingly with the k elements. So in this case, we have been given k equals 2, right? So we have to extract the top k elements. What we will do, we will pull top k elements from the heap. So we will be pulling top k elements from the heap, right? Accordingly with the k. So first poll here is 1, that is nothing but highest frequency with the 3. Second poll 2 with the second highest frequency, nothing but 2. These two things we will consider. So k equals 2 we have been given. From the priority queue, first 2 elements will be polling, right? We will be polling top k elements from the heap as I have said. So 1 and 2 we will take from the priority queue. So 1 and 2, why? Because 1 is having the max, this one. 1 is having the max count or max frequency here, 3, and 2 is having the second max count, nothing but 2. So these two elements will be considering 1 and 2, right? So finally, what we will do, we will return the output 1 and 2. So we will return the output 1 and 2 here in this case, right? This is fine. I hope the approach is completely clear. We got 1, 2 as output, and the output that they have given on the given for the question 1 is 1, 2 as well. So the approach works absolutely correct in this case. The output that we got is equivalent to the output that they have given for the first example in the question, right? So the approach works absolutely correct in this case. I hope the approach is completely clear. This is the approach that we'll be going with. So now we are familiar with the approach, right? As we are familiar with the approach, let's move on with the edge cases, right? Let's discuss the edge cases one by one here. So the first edge case here is the first edge case here is all elements are same. When I say all elements are same, we are considering all the elements within the array same number, right? We are considering the same number within the array. So we have 7 that is repeated 5 times, and k equals 1. K equals 1 they have given. So the most this one repeated element is 7, the 5 times. So that's what here in this case k equals 1 they have given. Most frequent element, first most frequent element, that will be 7 in this case, right? In this case only one unique number exists here, so it is the most frequent, quite obviously. So let's move on with the second edge case here. K equals the number of unique elements. So here we have all the elements are unique. You can clearly see 4, 5, 6, 7 in the array. So k equals 4 they have given, right? K equals 4 they have given, or we have considered. Since here all the elements are unique, all the elements must be returned in this case. So output that we got here is 4, 5, 6, 7. I hope this is clear, easy, right? So let's move on with the third step here, large input size. When I say large input size, we have 1000, this one, 1000 to 10 to the power of times we have, right? K equals 1 we have. In this case, we are going with the large input size. K equals, this is up to 10 to the power of times. 1000 we have considered, right? So this is up to 10 to the power of times, and k equals 1 they have given. So output will be 1000. So why the output here is 1000? Because we have only one unique number here. We have only one unique unique number that appears 10 to the power of 5 times. So that appears 10 to the power of times here. So it is the most frequent. So this number will be the most frequent, right? So here in this case, we have to consider the number 1000. This is fine. So this is for the condition large input size. Let's move on with the fourth edge case, elements with the same frequency. When I say elements with the same frequency, nums within this one nums array, we have 8 that is repeated twice, 9 that is repeated twice, and 10 that is repeated twice in this case, right? So that is the reason I have said this is for the edge case elements with the same frequency, right? All the elements are having the same frequency count here. 8 twice, 9 is repeated twice, and 10 is repeated twice in this case. K, we have considered k as 2. Then output can be either 8 or 9, right? Either 8 or 9, or 8 or 10, or 9 or 10, right? 8, 9 or 9, 10 or 8, 10. Output can be anyone you can consider, right? I hope this is clear. Elements with the same frequency. This is for the condition elements with the same frequency. These are the 4 edge cases that we need to consider here, right? So first one was for this one. All the elements are same. All the elements are same. The second one was for k elements with the number of unique elements. The third one was for large input size, and the final one or the fourth one was for elements with the same frequency, right? I hope all the edge cases are clear. Now we are familiar with the approach as well as the edge cases. As we are familiar with the approach and edge cases, it will be easier to write the code. Now let's start writing the code. Here, what we will do, what is the first step here? We have to count the frequency of each element, right? Before that one, I'll just initialize the map here. So let me give here. I have already said that we'll be making use of the hash map and priority queue. So I'll just give here integer. We consider integer. So this is fine, integer. Let me consider the variable name map here, new hash map. This is fine. What happened to this one? This is fine. So first step is we have to count the frequency of each element. So I'll just be making use of the simple for loop here, integer n of nums. This is fine. So I'll just make use of the put property here that is provided by the n comma. So we have to get the value, right? So we have to get the value or default value we have to consider. So I can make use of the get or default that is provided by the map. I'm speaking of the property. I'll just go with map dot get or default here. This property I was speaking of basically. Here n comma 0 plus 1, as this is 0 indexed. So this is, so the next step here is we have to create the max heap, or we have to create the max priority queue based on the frequency, right? We must create the priority queue. So I'll just give here priority queue in this case. So I'll just consider integer. So I'll just consider the variable name pq. So new, let me copy this one, priority queue. New priority queue. So this one we are sorting the elements in the descending order, right? So this one, what I'll do, descending order based on the frequency we are sorting, means 1 was repeated thrice, that came first based on the frequency, right? Means nothing but descending order based on the frequency. 1 was repeated thrice and 2 was repeated twice in our case. In the example, first example I'm speaking of, whatever we considered in the approach, right? That I'm speaking of. 2 repeated twice and 3 was 3 existed only once. So based on the frequency, means we will be we have to sort this one in the descending order. So I'll just give here in this case a comma b. So this will be, sorry, so what I'm doing here, so yeah, this is fine. Map dot get means we are going with b minus a, means map dot get value, right? So get means nothing but we are getting the value. So map dot get of, this is fine. So the next step here is, after the second step, if you remember, we have to add all the unique elements to the priority queue. All the elements we have to add. Then we will poll, right? Then we will poll accordingly with the k. So before polling, we have to add all the unique elements to the priority queue. So I'll be making use of the property add all from the priority queue. I'll just go with here pq dot add all. Here I'll just give map dot this one. Let me make use of the key set here. Key set. This is fine. Different key set, unique key sets, right? So we are adding all the unique elements to the priority queue with no duplicates. That is the reason I'm making use of the key set, right? I hope this is clear. That is the reason I'm making use of the property key set. I have repeated this one several times. Let's move on with the final step. We have to extract top k elements, or we have to poll top k elements from the max priority queue. We have to extract top k elements from the max priority queue, right? So this one I can write in this way. I'll just consider result variable res here. In this case, new int of k. This is fine. So let's make use of the for loop here. For int I equals 0, I less than k, right? So I plus plus. Let's increment the I here. This is fine. No need of this one. Flare bracket here. So iterated value of the result can directly give here pq dot poll. So we'll be making use of the poll, as I've said, as we had discussed on the this one approach itself, right? We know this one. Finally, what we will do, we will return the result. So we will return the result, right? So what we will do now, let me hit the run button. So let me hit the run button. So here somewhere, what I have done here, just give me a second here. Map, okay, this one I have given in the caps. Just give here, in this case I'll just make this to map. Let me hit the run button again. So yeah, you can clearly see the sample test cases are getting passed. Let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. So you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case, right? So the code works absolutely correct in this. So the code works absolutely correct in this case, right? So now what we will do here is, let's quickly discuss the complexities for the code that we have written, right? So here we know that the approach that we went with here is hash map plus max heap. So the approach that we went with here is hash map plus max heap, nothing but priority queue, right? So the approach that we went with here is hash map plus max heap, nothing but max priority queue here. So what will be the overall time complexity here? The overall time complexity here is big O of n in this case. Why it is big O of n? Heap operations will take big O of n log n because we are making use of sorting, where sorting is the dominant factor. In the worst case, it will be big of n log k, right? N log k in practice. We are extracting the k elements, right? So it will be k log n. It will be k log n, right? So overall, this one, overall time complexity would be big O of n log k, not the big O of n. It is big O of n log k, right? We are extracting the top k elements. We are sorting and we are extracting the top k elements. So it will be big O of n log k in this case. So what will be the space complexity here? The overall space complexity would be, in this case, it would be big O of n as well. So overall space complexity would be big O of n as well. Because the heap storage is big O of n here in this case. We know heap storage is big O of n and output array is big O of k. Overall space complexity we'll be considering as big O of n in this case. So the overall time complexity would be big O of n log k, and the space complexity would be big O of n in this case, right? I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.